Good morning, everyone. Today we are going to continue with chapter number 8, Architectural Modeling. So these are the contents from the chapter number 8, that is components, component diagrams, deployment diagram and collaboration diagram. In last sessions we have seen about components and component diagrams and examples for component diagrams. Now in this session we are going to continue with the deployment diagram. Here see the deployment diagram. So deployment diagram is used to model the static deployment view of a system. Static deployment view of a system. So it is important for visualizing, specifying and documenting embedded client server and distributed systems. So this deployment diagram shows the configuration of runtime processing nodes or runtime processing elements and the software components and the artifacts that live on them. So the deployment diagram is comes into picture whenever we are going to deploy that system to the end user. Here the deployment diagram contains nodes, components and the connection between that nodes and components. Here the deployment diagram is graphically, it is rendered as, or the deployment diagram is a graph of number of nodes that are connected by association links. So that is graphically a deployment diagram is a collection of vertices and arcs. So that your deployment diagram is a graph of number of nodes that are connected by a association links. So that association between these components shows the system interaction path, and nodes are composed of hardware parts like disk drives, client machine, server machine, processor. So these nodes are also called as components or logical elements which executes at runtime. So what is the purpose of deployment diagram? So purpose of deployment diagram is to visualize hardware topology of a system, then describe the hardware components, then describe runtime processing nodes. Then elements of deployment diagram. So elements of deployment diagrams are nodes. Like nodes means we can say that components. Nodes are also called as components or logical elements. Then communication between nodes or that connections. That communication between nodes, it may be association, dependency, generalization, realization. Then nodes and artifacts, then common modeling techniques of nodes. That common modeling techniques of nodes includes modeling processor and devices, modeling the distribution of artifacts. So these are the elements of deployment diagram. And another element is artifacts. So artifacts may be the deployment artifacts, work product artifacts, execution artifacts, and that common modeling techniques of artifacts are modeling execution and libraries, modeling tables, files and documents, and modeling the source code. Now see the elements of that deployment diagrams are like, first one is node. See the notation for node. Node means components. It is a three-dimensional cube with hardware name inside it. This is the notation for node. Okay. So it is a three-dimensional cube. Inside that we are going to write that hardware name. That hardware name like disk drives, client machine, server machine, processor or any networking structure name. So your nodes is it's just like an artifacts that are an important building block in modeling the physical aspect of a system. So it is a physical element that exists at runtime and represents a computational source. That node is a physical element. Physical element in the sense it is a hardware part that exists at a runtime. So that graphical representation of node is cube, three-dimensional cube. So types of nodes are processor and devices. So processor means it is a piece of hardware capable of executing programs, and a processor can have list of processes on it, and it is represented as a shaded cube with the name of object. And next type of node is device. So device means it is a piece of hardware incapable of executing program is called as device. It also device will also have on a cube. So this is the representation of a node. Inside that we are going to write that hardware name. Then the communication between that nodes or the connection between that nodes. So that connection may be like association, generalization. Here first one is association. Here association means it is a link between the two nodes or two components that connect with each other. See the communication, association, it refers to a physical connector. This is the association between these two nodes or link between these nodes. Here it refers to a physical connection or link between the nodes. It is shown as a solid line between the nodes. This is association between two nodes. Here one node is desktop client and another one is business processing server. Then next is dependency, that is communication between node is either association, and next one is dependency is shown by a dash arrow. Here you can see that dependency is shown as dash arrow. It is the relationship that indicates that a model element is in some way dependent on another model element. So here that application server is dependent on that file here, that is sql server.exe file. Okay, that is dependency between the nodes. So dependency of a node of that component is depicted as a, or it is represented as a dashed line. This is the dependency between these two nodes. That means this node is dependent on this node. This node contains one files. Okay, then next communication between the nodes is generalization. So generalization, it is a relationship between a parent node and child node. Here you can see the dependency between the parent node and child node. That means here child is dependent on parent. So it is shown as a solid line with triangle between the nodes. This is the generalization relationship between that uh, nodes, between two nodes. This is the communication between two nodes using generalization. And next one is realization. So it is a relationship between interface and classes or components that realize them. So it is shown as a dashed line with hollow triangle. Here you can see parser. Parser may be HTML parser. So here you can see the example of relationship between an interface and a class that realizes or executes that interface. This is the HTML parser and parser. Here you can see the realization between these two nodes. Then next part is the common modeling techniques of nodes. Before that, that use of deployment. So what is the use of that deployment diagram? We are going to see that the deployment diagram describes the runtime architecture of the processors. So that devices and software components model the hardware of the implementation environment. So it defines or it identifies the hardware capabilities that affect the performance of the system and its software configuration. So by using the deployment diagram, we are going to depict or we are going to describe that system overview, that systems hardware component of that systems. Then that elements of the deployment diagram. Inside that, we are going to see common modeling techniques of nodes. So first one is modeling processor and devices. Here you can see the deployment for the here you can see that modeling processors and devices here, ethernet, kiosk here, console, red farm. This is the processor, server is there, and the components that are connected to that processor or the devices that are operated by that processor. Then modeling the distribution of artifacts. Here you can see the number of nodes are connected to each other with the files here. Previously, this is the devices. Now artifacts. Modeling the distribution of artifacts. That artifacts contains these files. Then what is artifact? So here artifacts are physical entities Artifacts are physical entities that are deployed on nodes, devices, and executable environments. So artifacts are physical entities that are deployed on nodes, here like this, that are deployed on nodes, devices, and executable environments. So it is the physical replaceable part of a system, like executables, libraries, table files, and documents. So that artifacts can be table files, libraries, or executable files like this. Or standard stereotypes for artifacts are like file, document. See the stereotypes for the artifacts like files. This is the artifacts. Artifacts can be here file, document, source, library, executable, and script. So artifact must have a unique name. So you cannot duplicate that artifact name here. Artifact must have a unique name. Then the here we have seen that common modeling techniques and that artifacts for the deployment diagram. Now see the example for deployment diagram as the for deployment. This is the deployment diagram for ATM machine. So here see this is the ATM client. There are three nodes: ATM client, ATM server, and database servers. All are connected by the association between these nodes here. See the relationship between these nodes are association. Here ATM client is connected to ATM server and database server. These nodes are filled because these are the servers. Okay, and here this is the client. So the client communicate with the ATM server by using TCP/IP, and ATM server is connected to the database server. So this is a simple deployment diagram for the ATM machine. In deployment diagram, we are going to mention only hardware components inside here. This nodes is a here representation of node is a cube, and we are going to place the hardware name on that node. Then this diagram is for online shopping. Now see multiple clients are there. So these are the devices, or these are the what we can say clients are the devices, and these are the servers: application server and database server. See the difference between this representation of server and client. Okay, whenever we are going to mention any server or processor, this cube is filled. Okay, now here see the client is communicating by using private network with the application server, multiple on, because it is online shopping. So all clients are having their private network. By through that private network, they are going to communicate with the application server. That application server contains application server dot executable files, application server dot exe, and that application server is going to communicate with the database server by using LAN. That is, the database server is Oracle server. So yeah, see the process of the deployment diagram here. That client is communicating with the application server and fetching the data from the database using the database server. Okay, so this is simple diagram for the deployment diagram for online shopping. And next one is for the railway reservation system, deployment diagram for railway reservation system. So here multiple clients are communicating with the railway reservation server with the private network or their public network. Then that railway reservation system is connected to that application server and their database server. And their railway reservation system is also having one printer. This is another device. So these all are interconnected with this. So for railway reservation system, that client is going to access that railway reservation server. Then that server is going to communicate with that application server and fetch the data from database. So these are the components of that railway reservation system. Okay, so this is the simple diagram for railway reservation system. Then we are going to see that component part. Next part is component diagram. Sorry, we have seen that component diagram earlier. Now we are going to see the collaboration diagram. So this is the last topic from the chapter number 8. So here the collaboration diagram is used for, or it is used to show the relationship between the objects. Collaboration diagram is used to show relationship between the objects in a system. So collaboration diagram defines the communication pattern between the set of instances, or the communication between the objects is represented as a graph. So here both the sequence and collaboration diagram represents the same information but differently. Sequence diagram and collaboration diagram represent same information but their ways are different. Both the diagrams are different. Representation are different. So here instead of showing the flow of messages, it depicts the architecture of the object residing in the system as it is based on the object oriented programming. So an object consists of several features. Multiple object represents or multiple object present in the systems are connected to each other. So here the collaboration diagram, it is also known as a communication diagram. It is used to portray the object's architecture in the system. So the communication diagram or communication diagram is a in communication diagram it is representing the objects as a graph, or this communication between the objects is represented as a graph, or the vertices in this graph are objects. In collaboration diagram, vertices are objects and the edges in this graph are the messages. So these messages are sent between classes or objects or instances. Then collaboration diagram represents a relationship and interaction between the software objects. Then there is some similarities between that collaboration diagram and sequence diagram. So what is the similarity between that sequence diagram and collaboration diagram? Both diagrams have a sequence number. Both diagrams have sequence number which shows the time order of the message. It depicts two ways to model dynamic aspects, flow of control by ordering the flow of control by the organization. So that similarities between these two diagrams are both diagrams having that sequence number. And the difference between that sequence diagram and collaboration diagram is sequence diagram cannot illustrate any relation between objects and collaboration. Sequence diagram cannot illustrate any relation between objects and collaboration. So see the notations that are used for collaboration diagram. That notations are like actor, object, multi-objects and links. So first we'll see objects. The representation of an object is done by an object symbol with its name and class underline that is separated by a colon. So that means that object is like we are going to represent or render that object is rendered as in that rectangle with the name and that class is defined, or that name colon that class name and the underline. Okay, then that in the collaboration diagram objects are utilized in the different ways, like the object is represented by specifying their name and class. Object is represented by specifying their name and class. So it is not mandatory for every class to be appear here. So class may constitute more than one objects. In the collaboration diagram, firstly the object is created and then its class is specified. Remember this, in collaboration diagram, first object is created and then its class is specified. So to differentiate the one object from another object, it is necessary to name that object. Then next one is actors. Actor can be shown as in we have seen that actors in the use case diagrams. In collaboration diagram, actor plays the main role as it invokes the interaction. So here each actor has respective role and name. Each actor has its respective role and name. In this, one actor initiates the use case. And third notation is links. So that link is like whenever a message to be sent, there must be a link, that is association must exist between the classes. Also the association must be navigable in the required direction, like links between objects are shown in the same like association in the class model. We have seen that association in uh, all the diagrams, how that associations are shown or the links. Then next one is messages. Here messages are like it is a communication between objects which carries information and includes a sequence number so that the activity may take place. So it is represented by a label arrow which is placed near a link. Here messages are sent from the sender to the receiver and the direction must be navigable in that particular direction from one objects to another objects. That is navigation between these two objects and message flow from that one objects to another. So that here that a receiver must understand the messages. That means the messages are sent from sender to receiver and the direction must be navigable in the particular direction and the receiver must understand the message from which sender that message is from. Then see the components of that collaboration diagrams are like actor and see the messages. This is the association between this actor and object here. See the object, how we are going to present that object like object name, then colon and class name that is underlined. See the representation of object and messages with the sequence number. Message with the sequence number and association, then representation of object, then actor. See, this is sample or these are the components of a collaboration diagram like actors, messages, objects. See the multiple objects are interconnected and the message flow. One dot message, two dot message, okay, three dot message, four dot message, etc. Okay, these are the components of collaboration diagram. Now, when to use that collaboration diagram? We have seen that collaboration diagram. What is collaboration diagram? Now, when to use that collaboration diagram? So the collaborations are used when it is essential to depict the relationship between the objects. So whenever we have to define, we have to depict the relationship between objects. At that time, we have to use collaboration diagrams. Here you have seen all our objects. We are communicating through the objects at that time, whenever we have to show that relationship between objects, we have to draw that collaboration diagram. So here both the sequence and collaboration diagram represents the same information, but the way they are, but their representation or their notations are different here. So the collaboration diagrams are best suited for analyzing the use cases. So there are some use cases that are that by that we are going to implement that collaboration diagram. So first one is to model collaboration among the objects or roles that carry the functionalities of use cases and operations. Then to model the mechanism inside the architectural design of a system, we are going to draw the collaboration diagram. Then to capture the interactions that represents the flow of messages between the objects and the role inside that collaboration. So these are some use cases that are used for the implementing that collaboration diagram. Then see the example of collaboration diagram. See the object. These are the objects like window and the class name is user interface. Here, this is the object name window colon. See the representation of object here window. This is the object name, then colon and class name is user interface. Then this is the association. See this plain arrow here. Association between these two objects. Next object is a chain colon train chain. And see the links or the messages like with the sequence number like see the message first message make reservation user by through that object window we are going to send our first message is make reservation with the train chain, then second is make reservation, then third message is a seat. See the flow for the this collaboration diagram that we are going to reserve a seat for the train. So first we make reservation, then through the object chain, then make reservation at a train, then see each seat is available for the reservation. If it is not, see the loop here. Fourth message, each seat again, a self link is there. It will check for the availability of seats, and if it is available, then reservation and send a notice. That means see the confirmation here. Okay, this is a sample diagram for the railway reservation. Then benefits of a collaboration diagram. So benefits of that collaboration diagram or that collaboration diagram is also known as communication diagram. We have seen that. So it mainly puts emphasis on structural aspect of interaction diagram, that is how lifelines are connected or how that objects are connected to each other. So the syntax of collaboration diagram is similar to the sequence diagram, just difference is that the lifeline does not consist of tails in that collaboration diagram. And here another benefit is the messages transmitted over sequencing is represented by numbering. Each individual message is having a number. Here we have seen that each individual message is having a number, so that we are, it is easy to understand the flow of that diagram or the sequence of the diagram. Then the special case of collaboration diagram is the object diagram. It focuses on the elements and not the message flow. That collaboration diagram is focuses on the elements, not on the message flow, like sequence diagram. In sequence diagram the flow focus is on the message flow. Then the drawbacks of collaboration diagram. So in this collaboration diagram, multiple objects residing in the system can make a complex collaboration diagram. If multiple objects are there, then it is possible that it is there, that there may be chances of complexity. It increases the complexity if multiple objects are reside in the system, as it becomes quite hard to explore that objects. If multiple objects are there, it is complex to design that collaboration diagram, and it is a time consuming diagram. After the program terminates, the object is destroyed. This is the drawback of collaboration diagram. And if that object state changes, then it becomes difficult to keep an eye of an every single object that has occurred inside the object of a system. If that object state changes, that will reflect on that collaboration diagram. So these are the drawbacks of collaboration or communication diagram. Now see one example for the railway reservation system. Here, see the message flow. Object is P from the class passenger, then object R from the class railway system, and third is object T from the ticket here. And see the all these three objects are connected using that association. And see the message flow here. First one is login. Passenger has to log in here. See the message flow. First message is login. Here see the message login with the railway system. And here second is railway system is going to validate. And here see it will send the return status to the passenger. After validation, it will comes to the passenger. Then I can see the fourth message. It will request the form, and it will request form for the railway system. And that railway system here, see the number 5. If message is create form, it will create a form. Then see that after creating form, that passenger will fill the details and it will submit their details. Number 6, submit details. And here number 7 is create ticket. Railway system will create a ticket and it will send the details. Number 8, send details of ticket. Then ticket will send the uh, created ticket to, that is see the number 9, ticket created. It will send the created ticket to the railway system, and it will send the acknowledgement, that is number 10, to the passenger. That see that railway system saying that ticket to the passenger. And number 11 is take print. Passenger will take the print. Okay, so this simple collaboration diagram for the railway reservation system. Okay, so that's it for today's session. We will stop here. Thank you.